Nth roots. When you see this guy's known as a radical, and we're used to referring to that guy as a square root sign, but it's not. It's only when there's no number there do we use this to do square roots. It turns out that all along that there's been an implied 2 there that you just couldn't see. And what it meant is if there was two things that were underneath the radical sign, two factors that were the same, we could take out one of them. In fact, we'd take out both of them, and then we would only have one left over. That's what a square root does. For nth roots, or at least let's take a look at the next possibility, we'll call it a third root. For the third root, or cube root of a number, what we're looking for is three factors that are the same. If we have three identical factors, then when we take the cube root, they all come out as simply 1. So now with square roots, you might recall that occasionally we run into this weird situation where we have extra factors that are identical. So with a square root, it's completely reasonable to have 3 identical factors or more, and then you can only take one pair. In this case, we'll take this pair of 2's. You can take one of those 2's out in front, and then you're stuck with this extra 2 left under the radical. So square root of 8, when simplified, becomes 2 root 2. Turns out we can do a similar thing with cube roots. If we look at the cube root of something like, let's try 16. Well, 16 is 2 times 2 times 2 times 2. So there are 3 factors that are identical. So for that reason, since we have a 3 here as our index, what we'll do is we will take these 3 2's, take them out of the radical, put them out in front, and then we still have the radical, which is still a cube root, and we'll just have a 2 underneath. So that's how that works. I'll show you one more because I want to make sure you see a different kind. So what if I have something like this? Let's try cube root of 81. Well, 81 is 3 times 3 times 3 times 3. And so again, we have this deal where we have these 3 numbers that are the same. And so as a result, we'll take one of those 3's out in front, and then we'll still have a 3 left underneath. That 3 is still stuck underneath. And our final answer is 3 cube root 3. Now, this might actually be more obvious what's going on if we look at this with variables. With variables, it's really obvious to see how many we have. If I have x to the 5th and I have y to the 9th, then I can see exactly how many x's I have. So let's try taking the cube root of that. So x to the 5th, if I take the cube root, I've got, underneath the radical, I've got x cubed times x squared. That's what x to the 5th is. And then I have y cubed times y cubed times y cubed. So what happens is, since I have 3y cubed, since I have an x cubed, the cube root of x cubed, that guy becomes simply x, and we'll take that outside the radical. And then this is y cubed times y cubed times y cubed. So since there's 3 y cubes, I can just take 1 y cubed out in front of the radical. And then what I'm stuck with is this x squared. And it's stuck under the radical, just like this 2 was and that 2 before. And we still have a cube root. That does not change. So this would be our answer. Oh, one thing we'll always check to see with variables, did we start with an even power and did we end up with an odd power? And in this case, no, that did not happen. So no absolute value signs are necessary here.